We now want to look at simultaneous inequalities. We want to learn how we can solve two or more inequalities so that we can come up with a single solution set for those inequalities. So we're going to look first at example number 1. We want to find the set of values satisfying the inequalities. We have 2x minus 3 is less than 4 and 1 minus 2x is less than or equal to 6. Let's go on to the solution. You can see from our example that we've got two linear inequalities that we call simultaneous inequalities, simply because we want to solve them at the same time so that we can come up with a single set of values satisfying both inequalities. Alright, so I'm going to solve each one of them, starting with 2x minus 3 is less than 4. Now I know that we have learnt together in this topic how to solve linear inequalities. I would want you to work out this linear inequality so that you can come out with the values of x, an inequality that gives us the values of x. I want you to do that in less than a minute, starting from now. This is how I do it myself. I'm going to shift -3 to the right hand side, becomes +3, and I'll be left with 2x on the left hand side, and 4 plus 3 is 7. And then I divide both sides by 2, so that I'll be having 2 into 7.5, sorry, 2 into 7, that's 3.5. So I'll be having x is less than 3.5. Right, so that is the solution for the first inequality. Let's go on to the second inequality. 1 minus 2x is less than or equal to 6. Again, I want you to work out this inequality again by yourself. I want you to pause this video and start working on it from now. This is how I do it. I shift 1 to the left hand side, so to the right hand side becomes -1. I'll be left with -2x on the left hand side, and 6 minus 1 is 5. And I divide both sides by -2, but I'm cautious here because dividing by a negative number, the sign has to reverse. So -2 here divided to -2 will remain with x, but -2 into 5, that's -2.5. So the value of x will come out as x is greater than or equal to -2.5. So now I have my solutions. The solution for x from the first inequality, x is less than 3.5 and x is greater than or equal to -2.5. Now we want to combine these two solutions so that we can come up with a single set of values satisfying both inequalities. So to help me do that, I'm going to use the number line. I'm going to draw the graphical representation of both the solutions. So drawing the graph here, x-axis, I put the values -2.5 and 3.5 on it, with -2.5 being the smaller number and 3.5 the great bigger number there. So what I'm going to do next is I'm going to represent this inequality first on the number line on the graph. X is greater than or equal to -2.5. I shared on 2.5, and the values which are greater are to the right of -2.5. Again, for x is less than 3.5, this time I don't shade, it's an unshaded circle on 3.5, and values of x that are less than 3.5 are to the left of 3.5, so these will be the values. Now you can see here that we're coming up with a solution, a graph that represents values of x that are between -2.5 and 3.5, where -2.5 is included but 3.5 is not included, and you can see here that the circle here is not shaded, showing that that 3.5 is not included in our solution. This is written -2.5 is less than or equal to x, and x is less than 3.5. So that's our solution, the set of values satisfying the inequalities. So you can see here that it's a simple thing to solve simultaneous inequalities, to find a single set of values satisfying both inequalities. and I have example 2 for us so that we can solve it. In example 2, we want to list the integer values of x satisfying the inequalities. We've got -1 less than 2x plus 2 and is less than 10. Let's move on to the solution. I write down the inequality that we have been given, and here they'll come out two inequalities. The first one is -1 is less than 2x plus 2, and I'll write it down. The other one is 2x plus 2 is less than 10, and I'll write it down again. So we now have two inequalities that have to be solved. What I want you to do is I want you to participate. I want you to work out these two inequalities. Let's start with the first one right here. -1 is less than 2x plus 2. I want you to solve it. I want you to pause this video and start working from now. So this is how I do it. I shift 2 to the left hand side, becomes -2, and -1 minus 2 will be less than 2x. That's -3 is less than 2x, and I divide both sides by 2, so that dividing by 2, 2 into -3, that's -1.5. So here I'll be having -1.5 is less than x. Right, I hope you got that one correct. And let's look at the other one, this inequality again. I want you to solve it, so you can also solve this one in just a few seconds. 2x plus 2 is less than 10. I want you to come out with your own solution for x. What I do is I shift 2 to the left hand side, becomes -2. I'll be left with 2x being less than 8, because 10 minus 2 is 8, and I divide both sides by 2. Dividing both sides by 2, then I'll be having the value of x being less than 4. Alright, and for this inequality that we obtained here, if I want to write it with x on the left hand side, then the sign will turn the other way, so it will come out as x is greater than -1.5. So that's the other way of writing it. So now I have my two inequalities, the two solutions to the inequalities, and we now want to combine the two solutions so that we can come out with a single solution set. And remember, we said the graph can make our work easier. So I'll put the values -1.5 and 4 on the number line, and I'm gonna start with x is greater than -1.5. So if x is greater than -1.5, I put an unshaded circle over -1.5, and the values that are greater are to the right of -1.5. And again, for x is less than 4, I go on 4 and I put an unshaded circle there, and the values are to the left of 4. So you can see here that we come out with a graph that represents values of x that are between -1.5 and 4. This is written -1.5 is less than x, and x is less than 4. So what we have now is the solution set to our inequalities. But you see, our question does not just want us to have the solution set. Our question requires us to list the integer values satisfying the inequality. So we want to list the integer values that are satisfying the inequalities. So in other words, we want to look for the values, integer values that are within this range, within this solution set. So from -1.5 to 4, which whole number values, integer, remember integers are whole number values, either positive or negative. So this will come out as, we'll be having -1, and I will be having -1, 0, 1, 2, and 3. These are the values that are within the integer values that are within our solution set. From -1.5, we've got -1, 0, 1, 2, and 3. These are the integer values within this. Remember, 4 is not being included, though it's an integer. It's not included in our solution set, and negative 1.5 is not an integer at all, so it's also not being included in our solution set. So what we now have here is the solution, the integer values within the range. So that is the solution. That is how we can solve these simultaneous inequalities, and I'll be giving you more problems to work out.